Okay, so my screen is visible, right? Just to check.
Yes.
Sure. So yeah, we'll discuss some nice NT problems mainly, and just interesting divisibility ideas. So is a problem visible too?
Yeah.
Sure. 1 second. No, sir. One second. So let n and p greater than 1 be positive integers and p be prime. So we know that n divides p minus 1 and p divides n cube minus 1. Prove that 4p minus 3 is a prime. So just try the problem for 5 minutes, just get a feel of the problem. And then if you have any ideas, just say.
Okay. So since n divides p minus 1, so you have n less than equals to p minus 1.
Oh, 1 second.
Is my voice still like
No, your voice is much better.
cutting?
It's much better. Yeah. So
Yeah.
n.
So like n divides p minus 1. Yeah.
This. Yes, okay, better.
Which implies p is greater than equals to n plus 1.
Yeah.
Which means p cube is greater than equals to n plus 1 cube.
Yeah. 1 second, I'll write it again. Yeah, p
Wait,
cube is at
do you not
least
have
10
stylus
plus.
right now?
I have. It's working very bad.
Ah.
Yes, much better.
And we know p cube should be at max n cube minus 1 because of the second condition. So you can put that.
No, p divides n cube minus 1. Just p
Yeah, so
divides.
so p is less than equals to n cube minus 1, right?
Yes.
Oh, wait, p divides. Okay, never mind. I read it wrong. I read p cube divides n cube minus 1.
Yeah, I got it by cubing this.
Yeah.
If you want 4p minus 3 to be a perfect square, you want p to be of the form k square plus k plus 1?
Yes. This one. Yeah, that's right. So we want p to be something of the form k squared plus k plus 1 for some k.
K equal to n would work.
K equal to n would work. And is that the only thing? Well, maybe.
I hope so.
Maybe true. Hopefully. So we want this. I'll just write want so that people are not confused. Want My handwriting is so bad. But so any other ideas?
Wait, so P divides n minus 1 into n squared plus n plus 1, right?
Yes, that is correct. So P divides n
And
minus 1. 1 second, let me just write. Oops. Means n squared plus n plus 1. My hand is too sweaty, I guess. Yeah, this. Yeah, go ahead.
wait.
You're right. See, so this we get P. Yeah, go ahead.
So we know P is greater than or equal to n plus 1. So P cannot divide n minus 1.
Exactly.
So P divides n squared plus n plus 1.
Yeah,
And because p is prime, unless n square plus n plus 1 is prime, it will be smaller than root of thing. So it can't happen.
exactly. So does everybody got that?
Why n square plus n plus 1 prime?
Oh, otherwise P would be, if n squared plus n plus 1 is not prime. Wait, why should P be the smallest prime dividing that? P should not be the smallest prime dividing that.
Yeah, I got confused.
Yeah. Okay, no, that's fine. So what should we do now?
If you just let like replace p with nk plus 1 or nl plus 1 something.
Yes, exactly. I just move. Okay, no, 1 second. Oh, anyways. So just P to be some kn plus 1, just because we know n divides P minus 1. So we can write this. And so we have nk plus 1 divides n squared plus n plus 1. And now we just try to lower the degree of this thing. So this turns out to be something linear. And then we can do size ideas to get something nice. So first multiply this by k to remove the kn squared term. And then we subtract n times nk plus 1. Oops. Handwriting. Kn squared plus kn. Okay, this is kn plus k minus n. My god. 1 second, I just. So we have nk plus 1 divides kn plus k minus n.
So you have k's at least n plus 1, and that gives
a contradiction to p divides n squared plus 1. So from this we can directly say, just like, oops, for everybody, I'll just write it once. So we have nk plus 1 is at most nk plus. Wait, what is happening? K minus n. So disgusting. 1 second, I'm sorry.
I think this probably happens when Miro doesn't load correctly. So like probably try refreshing Miro.
Okay, I'll try doing that. 1 second, I'm sorry, people. Just 1 minute.
But like another reason of this happening is like probably your net is a bit slow because of Zoom combined.
Maybe. Like net is, I guess, 5G, not 5 years.
Or a Miro is like too heavy. You have too much stuff written on it.
That is true.
Yeah, that's the reason then.
Three
That's
Miro
what
boards
it-
with too much stuff written on them. I deleted stuff. Third, I'm sorry, people. Network bad. Yes, we're back. Okay. I will. Bad. I'll use one note from now on. Miro was good. So it's good, but anyways. Okay. So I just repeat what we are doing because network. So we first got that p divides n squared plus 1 because p cannot divide n minus 1 because of size issues. So we substituted nk plus 1 and then we were trying to reduce the degree of n squared plus 1 to something linear or smaller so that we could use this inequality to, so that this gives k is at least n plus 1. But this is not possible. Wait, this is possible. Like, oops. So initially we had p dividing n squared plus n plus 1. We had p divides n squared plus n plus 1. And hence we have nk plus 1 divides n squared plus n plus 1. And so this directly gives that k is at most n plus 1. So we must have that k is exactly n plus 1. And that f prime p is n squared plus n plus 1. And as said earlier, we needed just this form only. It's because you can just check 4p minus 3 is equal to 2n plus 1 whole squared as desired. So we are done. So is there any questions with the proof?
No.
Oops. Oh. So like just to like in this problem, we had like some weird divisibility and then we wanted to prove something is a perfect square. So straightly the conditions like directly they don't add up. So just try to extract as much information possible from the divisibility conditions. We may not be able to exactly characterize n and p. Like in this case, we were quite lucky that p were n squared plus n plus 1. But in general, we may not be able to characterize. Just try to extract as much information possible and you get an intuition that this should be sufficient to prove the statement. So similar problem like this. Okay, is this. So is the problem visible?
This is an absolutely brilliant problem.
This is very good.
Statement is beautiful.
So we need to find all positive integers n greater than or equal to 1 such that there exists a pair of positive integers a comma b and a square plus b plus 3 is not divisible by a cube of any prime and n is equal to ab plus 3b I agree to plus 8 divided by a square plus b plus 3. So n is equal to this fraction and a square plus b plus 3 is not divisible by a cube of any prime. We don't need to find all AB which satisfy. We just need to find an n such that there is one pair, at least one pair. So try this problem for 5 minutes and like get a feel of it. And any ideas, just say it. Okay, any ideas? Any ideas? Just like don't wait for full solution. Just 3a square plus.
Like we can take a is equal to b,
I'm sorry.
and then for a special case of it.
Can you repeat? I'm sorry.
Hello.
Yeah, you're audible.
I actually am taking a case of it like a is equal to b and then solving. I am getting n is equal to 2.
Yeah, so you're saying that n equal to 2 works. Satisfies the conditions, right?
But greater than n is equal to 3, we will not get any solution as 2a plus 5 is less than a square a plus 3.
So for n greater than equal to 3.
In this case, a is equal to b.
Achha,
We will not get any solution.
Okay. For a equal to b, when you're taking the special case of a equal to b, you're saying that there is no solutions for n equal
For
to 3.
n greater than 3.
Yeah, that is correct. That is correct. We try to focus on when a and b are not equal. So as a nice idea in the chat. So we have, first of all, this should be an integer, right? This fraction should be an integer. So we have a squared plus b plus 3 divides ab plus, what is happening? I was trying to test it, but now it's just trash. Divides ab plus 3b plus 8. So So we'll try to remove this 3b term. So just subtract 3 times a squared plus b plus 3. A squared plus b plus 3. So we get that this is equal to ab plus, okay, no, minus 3a squared minus 1. So we've got something like this. So now try to eliminate this ab by just say multiplying by a.
Now we can minus a into a squared plus b plus 3.
Yeah, that is correct. So we're going to go a squared plus b plus 3 divides ab minus cubic exactly. Now you'll see something really nice. Oops. Oh boy. 2 is exhausting. Minus 1 minus a times a squared plus b plus 3. So this simplifies to minus a cube minus 3a squared minus 3a minus 1. Does this look familiar?
Brilliant problem.
This is minus a
Do you
plus
not like this problem?
No, I like the problem. I think it has comedic value.
So this
Makes sense. That's why I was.
yeah, fine, you can say. Yes, so this is something super nice. And this cube, we've got a perfect cube. This does give some significance that why we were given that a squared plus b is not divisible by cube of a prime. Why this number is cube free. This gives some slight significance and maybe we're on the right track. So let's do more things with this. So essentially, what is the fraction this? A plus 3 whole cube. Sorry, a plus 1 whole cube. I'm sorry. A plus 1 whole cube divided by a squared plus b plus 3. So originally from the fraction, we first subtracted 3 and then we subtracted a. And then we like multiplied by minus 1. So this is equal to a plus 3 minus a. N, sorry. Now, oh, by the way, are people familiar with VP? Just asking.
Yeah, probably. That just took a class like last week or
Yes,
something.
sure. So I'll just
2 weeks ago.
yeah, fine. So we first of all have VP of for every prime, we have VP of a squared plus b plus 3 is at most 2. So this is what cube free says. Like a squared plus b plus 3 was not divisible by cube of any prime. So this is what it says. And so for any prime that divides a squared plus b plus 3, you must have that prime also divides a plus 1 whole cube. Just because this is an integer. So we must have that prime also divides a plus 1. So VP of a plus 1 is also at least 1. But for a squared plus b plus 3 to divide something, all we need is that VP of that something to be at least 2. And when we are cubing a plus 1, we're getting that VP of a plus 1 cube is at least 3. A plus 1 whole cube. Oops. Whole cube. This thing is at least 3. So all we need for a squared plus b plus 3 to divide some number is that VP of that number to be at least 2, right? That would be sufficient for a squared plus b plus 3 to divide a number. Does that make sense? Okay, I should repeat, I guess. So what we first did, we had that a plus 1 whole cube divided by a square plus b plus 3. This is equal to a plus 3 minus n. And we are given that a square plus b plus 3 is cube free. That is, it is not divisible by cube of any prime. So for any prime p that divides a square plus a plus b plus 3, we must have that vp of a square plus b plus 3 is at most 2. Are there any questions till this?
No.
Fine. So we must have that for any prime that divides a square plus b plus 3. P must also divide a plus 1 whole cube. And so P must also divide a plus 1. So the VP of a plus 1 must also be at least 1. Is this part clear?
Yeah.
And so just because we are, so for a square plus b plus 3 to divide a particular number, say if a square plus b plus 3 divides some number m, so if we can ensure that for every prime p that divided a square plus b plus 3, if vp of m is at least 2, if we can ensure this, that would suffice this, like this implies this. Is this clear? Like this is for all primes that divide a square plus b plus 3.
Yeah, okay.
Is there any questions to anybody else you can ask to? So I'm assuming that there's no questions. So this means I know that we had VP of a plus 1 is at least 1. So consider a plus 1 whole squared. Now VP of a plus 1 whole squared is at least 2. This implies that a square plus b plus 3 also divides a plus 1 whole square.
Oh, right.
So we strengthened it from dividing a cube to dividing a plus 1 whole square. So now a plus 3 minus n, this was equal to a plus 1 whole cube divided by a squared plus b plus 3, which we can rewrite as like a plus 1 times brackets because that's annoying, times this quantity, this is squared, this is a 1, divided by a squared plus b plus 3. And then we know that this is an integer. So this is some stuff we don't care about. All we know is that this stuff is an integer, positive integer. And so this is also positive, just like sure. And so we must, so a plus 3 minus n is equal to a plus 1 times some integer. So a plus 1 must divide a plus 3 minus n. Right? And as a plus 3 minus n is positive, so we must have that a plus 1 is at most a plus 3 minus n. And hence n is at most 2. Are there any questions till now?
No.
Nice. So we have limited n to 1 or 2 just because n was a positive integer. Awesome. Brilliant. So somebody in the beginning said that n greater than equal to 3, the pair a comma b doesn't work. So you were right that n greater than equal to 3, no pair works. But so is this part clear?
Yeah.
Awesome. So can n equal to 1 work?
No, I don't think.
Why?
Put it into that divisibility, you get a plus 1 divides a plus 2.
Exactly. So if n equal to 1 would work, then this divisibility would have given that a plus 1 divides a plus 2, which is not possible just because a is a positive integer, so this is at least 2. So n equal to 1 doesn't work. So the only thing that works is n equal to 2. And somebody in the beginning said that there is a pair of the form a comma a which satisfies for n equal to 2. Which was, what was the pair you got?
Two comma two.
Yeah. So we've limited that only n that can work is n equal to 2. And somebody found that the pair 2 comma 2 of a comma b satisfies the conditions. So the only solution is n equal to 2. Ooh, yeah. It's a really nice problem. And that's it. Any questions with the proof? So assuming there are no questions, so I also really like this problem. So we didn't even find all AP. We didn't even have to find all AP. Neither did we got some nice properties about AP. All we did was some nice manipulations. And once we reached this whole cube, that did give out some significance of why this cube is there. So these kind of hints should lead ahead, and that this is the entire idea. This is just intuition that one second. Died. Yeah. So once we got that a plus 1, the a squared plus b plus 3 divides a plus 1 whole cube, this should give that we are on the right track. Just because this cube appears somewhere. And then just noticing that a squared plus b plus 3 was cube free. And what does the condition actually mean that a squared plus b plus 3 to divide a number? And then we can reduce the 3 to 2 that a squared plus b plus 3 also divides a plus 1 whole square. And then going back, and then the proof was clear, right? So really nice problem. Again, we did not find all AP. We did not characterize all AP. We just did nice manipulation to find all positive n. Did that make sense? What I tried to just point out. Yeah, if we had n equal to 2, you would get that all pairs of the form a equal to 2b minus 1 work. And a squared plus b plus 3 should be cube free. That's what we also had to ensure. But
For a 1 square free.
I'm sorry, I didn't forget that.
A square plus b plus 3 in that case would just be a plus 1 square. So you just want a plus 1 square free.
Yeah. So all you want is a plus 1 to be not divisible by what? Not to be a perfect cube. Sorry. No. It should be square free. That's all we need. A plus 1 to be square free. So anyways, 2 comma 2 satisfies. We don't need anything more. Awesome. Oops. Mirror hand here. Read stuff on the mirror. Now, a similar problem.
Why does this exist?
It's a good problem.
It's a hard problem.
It's fine. It's not that bad. It's a good problem. I like this problem. So positive integers a, b
You
satisfies.
don't make better choices.
No, this is good. It's so nice problem.
Fine, let's try. The equation doesn't look nice. It's not even symmetric.
That's the best part, right? Was the previous problem's equation symmetric? No. And it turned out to be so good, a plus 1
Fine.
cube magic. This also is
Yeah,
not
fine.
bad. Okay. There's some nice magic that happened. So we have some weird equation which is not symmetric, and a, b, c satisfy them, and a is at least c. And the number p equal to a squared plus 2a plus 2 is prime. We want to prove that the prime divides a plus 2b plus 2. So try it for 5 minutes. Just get a feel of the problem. Any ideas, just say the idea, like, of course, 5 minutes is not sufficient to solve the entire problem. Just give any idea. Yeah, P is equal to A plus 1 whole square plus 1. So A plus 1 whole square plus 1 is a prime. So let's just write it. P is equal to A plus whole square plus 1. A divides 4B plus C. Yep, that is correct. So we got A divides 4B plus C. Oh my. B is strictly greater than A. That is correct too. I'll just explain from it. Okay, fine. That is
Why is B greater than A from this?
like I did it by C to B. C times AB minus 1 is equal to, whoa, wait, bad Miro, bad, is equal to AQ plus 4B. And then this is at least A squared B minus A, giving that, oh, I'm sorry, I flipped inequality sign. This is the other way around. Yeah, so we have A squared minus 4 times B is at least A cube plus A. So if B were at most A, you would have that this is at most A cube minus 4A, which is not possible. This is if B were at most A.
Makes sense.
So this is not possible. So we have this. So is this clear to everybody?
Okay, also I don't remember the solution. I did this a while back. But the way P is, it divides A4 plus 4.
We just gave it away. Yes. P
How does-
divides it to the 4 plus 4 because of Sophie Germain identity. Okay, fine. They did not give it away, but there's still some steps. So we get this. But so the expand, like classic factorization stuff. She learned in 7th grade.
Classic JE stuff.
Yes, classic J stuff, better. Classic J stuff, this factors to this. 2a plus 2. My 2s are so good.
A square plus 2a plus triangle.
2. Is this better?
Yeah.
A squared minus 2a plus 2. Yeah. Okay, this factors to this. Awesome. So if p divides a to the 4 plus 4. Magic. Anyways, how do you utilize this better? So if you look at the statement, we have some expression in A is a prime, and we want to prove that prime divides some expression in A and B. So C is not making much of an impact other than this equation. So just try to remove C and just focus more on AB. We get some divisibility, probably, and then just focus on A and B.
So you get AB minus 1 divides A cube plus 4B.
Yeah.
And that quotient is at most A or whatever.
So we have this. So from this we get that C, just because C is a positive integer, AB minus 1 divides A cube plus 4B. Whoa, boy. Awesome. And the quotient was at most A would give this inequality. That is just this inequality that we got right. From C is less than equal to C is less than equal to A, right? So A squared minus 4 times B is greater than equal to A cube plus A.
Oh, so this gives AB minus 1 divides A4 plus 4.
Yes, exactly. Awesome. So how did we get that? One motivation is that A appears much more prominently than B in the last part, right? So focusing more on A would be better than they try to limit B as much as possible. And if we are not like Atul to see this nicely, Atul sir.
Like just put B as 1 by A.
Yeah, in this we can get like, I'm saying we first saw this, right? That does give to stitch A to the 4 plus 4 somewhere here. So if we didn't think this, then just put B to be 1 by A, or yeah, just put B to be 1 by A. We can get AB minus 1 divides A cube plus 4 divided by B, 4 divided by A, I'm sorry. Just because we are working modulo AB minus 1, I just tell B, AB is congruent to 1 mod AB minus 1. So we have that B is congruent to 1 by A. Fine. Is this clear, right? Is any step going too quick? Are people following? Ooh. Should I repeat like from which part? Hello, am I audible? Second, oops. Audio die? No, it's fine. Hello.
No, you're not audible.
Okay, fine. Like, was that a joke, right?
Yeah.
I know this because how could you answer that question if I was not audible? But is the proof clear? From which step should I repeat if it's not clear? Like what we are doing right
Are
now.
we done?
I'm sorry.
How are we done?
No, we are not done. That's what I said. We are not done. Till now, is everything clear? Are there any questions? Is nothing clear in the chat? I got a proof in somewhat other. You can say that. You're free to say. 1 second, Costa. I'll just explain. 4 by A just because we're working modulo AB minus 1. So B is congruent to 1 by A mod AB minus 1. So we can write, okay, like fine, remove denominators. So this is like whatever, I'll just write A inverse. I won't write. Eraser. I won't write 1 4 by A, I'll just write A inverse. A inverse modulo B minus 1. Yeah. Fine, so we'll talk about this later. So Costa, what was your idea? You can say it.
Can you just scroll up so that I can
Yeah.
show it?
This, right?
Actually, if you see that equation a cube plus 4b plus c is equal to abc, a cube plus 4b plus c divided by abc, can it be equal to 1?
It should be equal to 1, right?
Yeah, it is equal to 1. So now, like, you divide each and every term from it, like a cube by abc plus 4b by abc. You can do that, right?
Yeah, you can do that. A squared by bc.
Yeah.
Plus 4 by ac.
Plus 1 by ab.
Yep, that is correct.
Is equal to 1.
Yep.
So I took it in a way such that only one term can be 1 here. The addition of other two terms must be equal to 0. Something like that.
I see. So you're trying to do a bit in size of these, right?
Yeah. So I assume that a square by bc plus 4 by ac. So how I assume those two as a square by bc is equal to minus of 4 by ac. I did something like that.
But like you're given ABC at positive integers, right? So like
No, whole term is negative, not like.
yeah. But all these terms are actually positive, right?
Oh yeah.
I don't know. Maybe this can be a solution. I haven't thought about in this way. It's nice, man. We can just probably comment on the size of this.
Yeah, like consider my 4 as negative. No.
If we can't do positive, negative, we can just say after some time, all of these are at most 1 by 3 or something like this. I'm not sure. I haven't thought about it. Maybe this may lead to a solution, a nicer solution.
I did not observe that negative thing over there. I just.
That's fine. That's fine. And in the chat, somebody saying P divides AB minus 1. So how did you get that? Or was that a mistake? I don't know. Oops. Okay, by mistake. Actually, that is true, but fine. So let's go back what we were doing. So we had AB minus 1 divides A cube plus 4A inverse, which is equal to A to the 4 plus 4 times A inverse. And as A inverse is co-prime to AB minus 1, we can just say AB minus 1 divides A cube plus 4. And if, okay, so A to the 4 plus 4, I'm sorry. If this A inverse part is a bit unclear, should I explain it again? Like to get that, just multiply this by A and then subtract 4 times this. Don't use A inverse, I'll just try to limit it if it's not clear. Yeah, I'll just do it that way. Fine. Right click. So I'll just do it like this. So we have AB minus 1 divides A to the 4 plus 4B. 4AB, multiplying A cube plus 4B by A. And then we'll subtract 4 times AB minus 1. And note that this just turns out to be a to the 4 plus 4. So we have AB minus 1 divides a to the 4 plus 4. And we also had P divides a to the 4 plus 4. So we have AB minus 1 and P both dividing a to the 4 plus 4. This means that the LCM of AB minus 1 and P both divide a to the 4 plus 4. So LCM of AB minus 1 divides a to the 4 plus 4. So what can LCM of AB minus 1 comma P be? Like P is a prime. So the LCM can either be P times AB minus 1 or it can be AB minus 1, right? Oops. Is this part till now, is anything not clear or are there any questions? Yeah. One second, like, are others people? Is this clear to everybody? Yes, I'll just move on. So yeah, as in the chat, if the LCM of P times AB minus 1. So remember we had that B is greater than A. So this term is about like at least greater than A squared minus 1. And P is A squared plus A plus 2. So multiplying this is about like larger than A to the 4. But if this divides something of the form A to the 4 plus 4, we should get some size issues. So just making this formal, if P times AB minus 1 divided A to the 4 plus 4, this divided A to the 4 plus 4. So we must have that P times AB minus 1 is at most A to the 4 plus 4. And this is equal to P, like, okay, fine, I'll just put at least. This is at least A squared plus 2A plus 2. Just because P is equal to A squared plus 2A plus 2. And AB minus 1 is strictly greater than A squared minus 1. So we can just put this like a strict inequality. But note that. So we have like, okay, fine, let's just write it next line. It's clear to everybody. So we have A squared plus 2A plus 2 times A squared minus 1 is at most A to the 4 plus 4. But note that this was equal to A squared plus 2A plus 2 times A squared minus 2A plus 2 times A squared minus 2A plus 2. So this cancels. And you have A squared minus 1 is at most this, which gives 2A is at most 3. And hence A is less than equal to 1. But, well, like this should not be true. We just check. So what if A is equal to 1? Going back into the statement, C is, first of all, we have this to give us that C is equal to 1, 2. But putting back, we have 4B plus 2 is equal to B. Clearly not possible. So A is not equal to 1. And thus, why did we do this? Is when we were taking the case of LCM of AB minus 1 to be P times AB minus 1. Right? So P times AB minus 1 cannot divide A to the 4 plus 4, just because this is not true. Is this clear? Is this clear to everybody? Are there any questions? And if it is not clear, what should I repeat? Yeah, we have. So this part is clear, right? That LCM is not AP times AB minus 1. So we'll move on, I guess. So we have that the LCM cannot be this, and hence the LCM must be AB minus 1. Now, when can the LCM be AB minus 1? When P divides AB minus 1. So we have got P dividing AB minus 1. And we wanted to prove that P divides A plus 2B plus 2. So we have got P divides some nicer quantity, much better than what we had before. So hopefully this may finish. Now we'll just do some bounding stuff. So we have A squared plus 2A plus 2 divides AB minus 1. And we want to remove this term AB. So just multiply this by A and then subtract things. Let's just do it 1 second. So we have A squared plus 2A plus 2 is divides, multiply by 2 and add P. Okay, I'll do that. So we multiply by 2, we get 2AB minus 2. Oh, I see. Oh, I didn't read the above messages, I'm sorry. 2AB minus 2 plus A squared. I see, that is clever. Okay, so the 2 cancels and we get what we wanted to prove. Nice, so I'll just say this again, so it is clear to everybody. So we have A squared triangle plus 2A plus 2. Wow. Some shit. A squared plus 2A plus 2. This thing divides, we multiply by 2, twice of AB minus 1, and add B. B is A squared plus A plus 2A plus 2. Which is equal to A squared plus 2AB plus 2A, which we can like factor out in A plus 2B plus 2. Hallelujah. Yeah, so A is clearly co-prime to this, which was a prime, and so as A is less than P, so it's co-prime. So we must say that our prime also divides A plus 2B plus 2, as desired. So are there any questions with the proof? We are done. Fine. Yes. Are there any questions with the proof? Hello. Like, is the proof clear? Are there any questions with the proof? Is there any questions with the proof to anybody? You can just ask, right? Please ask. So I'll just reiterate it quickly. Yeah, so what we did, we tried to remove the variable which does not have much of an impact to the problem, which was C. And then we got that AB minus 1 divides AQ plus 4P. And then a really nice observation that P divides A to the 4 plus 4. And then we simplified A cube plus 4B by multiplying by A and subtracting stuff. We got that AB minus 1 also divides A to the 4 plus 4. And P divided A to the 4 plus 4. So the LCM of AB minus 1 and P also divides A to the 4 plus 4. Now, just because P is a prime, the LCM of AB minus 1 and P is either P times AB minus 1 or it's just P AB minus 1. So if it were AB P times AB minus 1, we had some size issues that both are at least A squared and all. Both P and AB minus 1 is at least A squared, which gives some contradiction after some case flashing stuff, but that's fine. So some size issues gives that P times AB minus 1 cannot be true. That is the LCM of AB minus 1 and P must be AB minus 1. That is when P divides AB minus 1. And then a really nice observation that multiply AB minus 1 by 2 and add P. So like some nice divisibility manipulations can get that. We get that P divides A times A plus 2B plus 2. As A and P are co-prime, we got P divides 2A plus 2, A plus 2B plus 2, which is exactly what we needed. So I hope this is clear. We'll move on. We don't have much time left. This one. Yes, Prana's favorite problem. So find all pairs of positive integers AB satisfying the following conditions. We have A divides B to the 4 plus 4, P divides A to the 4 plus 4. I'm sorry. A divides B to the 4 plus 1, B divides A to the 4 plus 1, and floor of root A is equal to floor of root B. Just because we don't have much time left, should I do an easier problem? Or do you want to try this? Yeah, we can just bounce stuff. That is right. So do you want to try this? This is slightly, may take longer than 20 minutes. Not sure. Just because the previous problems took more than 1 hour. So do you want to do an easy problem or this one only? Am I audible? Hello. I guess I'm not audible, I guess. View settings. Hello. Can I get to know what is floor? Let's see question in detail. Can you get in what is floor? You're talking about this part? Just to
Yeah.
make, yeah. So, okay, I'll just do a different problem then. We'll just forget about this. Or if you want to try, I'll just do it, whatever people want. So floor is the smallest floor of n for any, okay, floor of x for any real number x is the smallest integer. So it's the largest integer at most x. This is largest integer at most x. Largest integer at most x. Integer at most is less than equal to x. For example, floor of 2.1. So what is the largest integer less than equal to 2.1, which is equal to 2, right?
Yeah.
So say floor of pi. What would this be? So floor of pi would be floor of, say, like pi is what, 3.14 something, right? So what is the largest integer less than equal to this? It's 3, right?
Yeah.
It's clear, right? So just because we're working in some square roots, what is floor of square root 17?
4.
Yes, that is correct. And fine, this is all we need for this problem. You can just Google floor function and ceiling function. There's a lot of stuff available on that. Okay, so should we do an easier problem, or should we, do people know orders? Like this problem does use that. Should have said that. Does you people know orders? Like order modulo n and stuff. If you don't know it, I don't think we have sufficient time. We'll just do a different problem. Hello. If people don't know it, like you can just say, we'll do a different problem. Oh, I'm sorry. Yeah, B to the A comma A does not work just because, like, yeah. Do people know orders? Fine. It's slightly longer. Should I do this problem? Are people comfortable with orders? If you're not, you can just say we'll do a different problem. I think I'm audible. Anything is fine. Sure, then we'll do this only. So as suggested in the chat, we first have that b to the 8 is congruent to 1 modulo. Just because we already had b to the 4 is congruent to negative 1 modulo A. This does imply that the GCD of AB is 1 and order exists and all. So whatever the order is, order of B modulo A, this divides 8, but this does not divide 4. But it does not divide 4. Right? Because B to the 8 is 1 mod A, and B to the 4 is not 1 mod A. This just directly means because divisors of 8 are 1, 2, 4, and 8, and 1 to 4 divide 4. So these are cannot be the possible values. So the order of B modulo 8 is 8. Unless A and B are like 1 or 2, we can check that. So if A is equal to 1, you can easily check that to get B is also equal to 2 or 1. And similarly, the other cases. So 1, 1, 1, 2, and 2, 1 all satisfy. So awesome. So the order of B modulo 8 is equal to 8. We can remove the divisibility sign and we can just take 1. Nice. So for any prime P that divided A, we still have that the order of B modulo P is equal to 8 because of the exact same ideas. And hence P 8 divides P minus 1 just because B to the P minus 1 is also 1 mod P and we have B to the 8 is also 1 mod P. So 8 must divide P minus 1. Thus P is 1 modulo 8 and numbers 1 modulo 8 are say 1, 9, 17 and so on. But 1 and 9 are not prime. So any P that divides A must be at least 17. Is this clear? Just write the yes. Is this clear? Yeah, thank you. This means that A is at least 17 and a similar condition holds for B. That is B is also at least 17. Awesome. So now let's analyze more about the divisibility, right? So we have A divides B to the 4 plus 4. And we have B divides A to the 4 plus 4. Can we make this slightly better? Because assume A is greater than B. So can we make this better? Because A equal to B can't work, co-prime. So can we make this better? Like when we're considering modulo B, when we're considering A to the 4 plus 1 modulo B, we can reduce, this is congruent to A mod B to the 4. Plus 1, right? So we can reduce A to be A mod B. And what is A mod B? So what can we say about A modulo B? It's less than B, but like, can we give a nice form? Like what is A minus B? Note that A minus B is less than B, right? Why? Because we have floor of root A is equal to floor of root B. So let's say this was equal to N. So we have A is equal to N squared plus X. And B is equal to N squared plus Y. And just because A and B are less than equal to N squared plus 2N. I'll write it better. This is less than equal to A and B is at least N squared. So the difference of A and B is at most 2N, which is less than B, right? Is that fine? Or am I just going too quick?
You are finally taking this question. I am happy.
Yes. You left. I said Pranav's favorite question.
My phone switched off. The battery was at 1%.
Yeah, that's fine. That's fine. So is this clear or am I going
So
to?
I did it way differently.
Huh?
My solution is way different, I think.
Oh,
It doesn't use orders at all, as far as I remember.
nice. Like my first, when I just first saw the problem, it has to be orders. Even though the order idea is kind of, I got stuck on it for some time.
Why did you feel it's orders? What?
I mean, B to
Oh,
the
I
4
see.
plus 1, bro.
Yeah. I
That
see.
directly says the order is 8. I was doing so much stuff with primes and random cyclotomic stuff. No reason. Realize this is a P4. Even though this is hard for a P4.
What?
I mean, this is not that easy for a 4. Your voice is breaking.
Oh, your method is contrived. Like there's a very simpler method.
It's not. It's not contrived.
It
Okay?
has switch Wi-Fi.
It's not contrived. You can easily get what I'm just trying to tell. And after that, it should be auto. Okay, fine. I'll go back. Hi, people. I'm back. So, can we say that A modulo B is A minus B? Is this part clear? Or did I just go way fast? If it's not, I'll fine, explain it again. Yeah. Oh. Yeah, so we have A and B are between n squared and n squared plus 2n. So the difference A minus B is at most 2n. So we have that A minus B is less than or equal to 2n. Stupid. A minus B is at most 2n, which is less than n squared. Just be at most n squared, which is at most B, right? Is this fine? So we have that B divides A minus B to the 4 plus 1. Is this fine? Just type yes in the chat.
Yeah.
I mean, okay, you know solution. Is it fine to other people? Yes, thank you. So we have this, but this looks much more symmetric, right? A minus B is so symmetric, and the original was so symmetric too. So this does give some hint that we may combine these both into one divisibility. And so I'll just give it away because of time issues. That is this true? Does A divide A minus B to the 4 plus 1? Is this true? Just type yes in the chat or no in the chat, whatever you think. Is this true or no? I think yes. I'll just make sure. So what is A minus B modulo A? It's negative B, right? And what is negative B to the 4? It's B to the 4. So A minus B to the 4 is congruent to B to the 4 plus 1, which was 0. So this is also true. Brilliant. So now we have that A and B both divide the same number. So the LCM must divide the same number. But GCD of AB was 1. So AB divides A minus B to the 4 plus 1. Awesome. Much better. Now, why is this much better? Like, we first had that A minus B is at most 2n, right? We know that this part is at most 2n to the 4 plus 1 or whatever that thing is. We can write it at most 2n just because A and B are co-prime. So n squared and n squared plus 2n. A cannot be n squared and B cannot be n squared plus 2n simultaneously because A and B are co-prime. So we can write this. I know that we have that A and B are both at least n squared. So this is at least n to the 4. So kind of in terms of n, both are degree 4. So this gives something nice, and this must be much better than what we earlier had. So what I'm trying to say first of all is that we have n to the 4 is at most AB, is at most A minus B to the 4 plus 1. So A minus B is at least n. And we know that this is at most 2n. So A minus B to the 4 plus 1. And on the other hand, like this is this part that we've used till now. And so now we'll use this part. So we have, this is at most 2n to the 4, which is 16n to the 4. So the quotient of a minus b to the 4 by ab, this part, this is at most 16. Is this all of this make sense? Just type yes in the chat, or no if this does not make sense. Awesome. So whatever the quotient is, it's at least 1 and 16. Much better. Much better. Now what do we do? Now, first of all, just we are working so much in n, so just get rid of a and b. So substitute a to be n squared plus x and b to be n squared plus y. We have that n squared plus x times n squared plus y divides x minus y to the 4 plus 1. Just removing ab and substituting the n squared plus x plus y. Awesome. What can we say about this? The quotient is very small, like it's just 1 to 16. A bad idea to just bash all cases, but we're not going to do that.
That's actually not that bad, like in one step only you can remove that. Nothing bigger than 2 or 3 works.
Exactly.
Like that.
Yeah, that's what we'll do.
I mean, that's not bashing, like.
Arey bash matlab and x minus y to the 4 plus 1 is equal to 2 times this, then solve this. Then 3 times this,
Oh,
then
no,
solve it.
okay, fine.
That is what bash means. We're not doing that.
Yeah.
We do something much better. How? Any idea? AB divides this. Oh, there should be a plus, like a to the 4 plus b to the 4 plus 1, I guess. Yeah, so we have AB also divides a to the 4 plus b to the 4 plus 1. Awesome. So what should we do now? How do we remove the 16 quotients? How do we utilize this somewhere? We don't have time, so I'll give it away. Now, we did some stuff about orders in the beginning, right? We proved that any prime that divided A must be at least 17, right? So what did we essentially use? We just used that we are the thing that we are the multiple, but this part says something to the 4 plus 1. That's all we used, right? So we'll just try to do it again. So pick a prime P that say divides this thing. We have that prime P divides x minus y to the 4 plus 1. So again, we get that the order of x minus y modulo P should be 8. Is this clear? Type yes or no in the chat. Awesome. So P's must be at least 17. So any prime that divides this quantity must be at least 17, right? So what about the quotient? Note that the quotient also divides x minus y to the 4 plus 1, right? Call this quantity m. We have that m also divides x minus y to the 4 plus 1, right? Type yes or no in the chat. Okay, I'll repeat it again. So we substituted a to be n squared plus x and b to be n squared plus y. And we got that n squared plus x times n squared plus y divides x minus y to the 4 plus 1. And we had a good bound on m, which is the quotient, that is x minus y to the 4 divided by n squared plus x times n squared plus y. So we have that m is less than equal to 16. right? Type yes or no in the chat.
Oh, my solution is actually different. After I complete, I'll tell my method.
Yeah, sure. I want to hear it too because interesting. I couldn't find a nicer way to finish this.
Yeah, like you do not have to do this like order stuff there. It's easier.
I mean, after the 16 part, okay, I'll come to that later. First,
Yeah.
are people comfortable with what you've done so far? If there are any doubts, I can repeat. Type yes or no in the chat or whatever question that you have. Hello, people. Type yes or no in the chat. Okay, I'll ask it again. Is everything clear? Type yes or no in the chat. Oh boy. Yes, finally. Okay. So is everything clear to everybody? Or are there any questions? I'll be happy to answer. Final move on F cross state 30. So we have that m divides x minus y to the 4 plus 1, 2, right? We also had this. So the exact same idea also happens to be true with m. That is, if m had a prime factor p, we could still say that p is at least 70. And hence, just because p divided m, we have that m is also at least 70. But m is less than or equal to 60. Contradiction. Thus, m does not have any prime factor. Hence, m must be 1. Does that make sense? Type yes or no in the chat. Or if there are any questions, you can ask. Yes, awesome, right? We've reduced all cases from 2 to 16. We only have m equal to 1. That is n squared plus x. I guess my handwriting is an issue. N squared plus x times n squared plus y. This is equal to x minus y whole to the 4 plus 1. Awesome. All we got to do is this not bad equation. Remember, we had x minus y is at least n, right? And now we'll just bound. Just because it does seem that x minus y is much smaller than the left-hand side, right? So we know that this is at least, at most, like x and y are at most 2n. So this is at most this. Right? So we must have that. Also, we can just put a strict inequality just because x and y have GCD 1. Sorry, n squared plus x and n squared plus y have GCD 1. So both can't be 2n. So we have that x minus y whole to the 4. This is at most n squared plus 2n whole squared. So x minus y whole squared is at most n squared plus 2n. Which is less than n plus 1 whole squared. Hence, x minus y is strictly less than n plus 1. So x minus y must be n. Fine? Any issues? Is this clear? Type yes or no in the chat. Yes. Awesome. So we have got that x minus y is equal to n. So we have that n squared plus y plus n, just because x is y plus n now. Y plus n times n squared plus y. This is equal to n to the 4 plus 1. Awesome. Now this quantity is at least n squared times n squared plus n, just because y is greater than or equal to 0. But this is equal to n to the 4 plus n cube. Hence n cube must be at most 1. Hence n is at most 1. But we've got rid of n equal to 1 in the beginning. So there is no more solutions for n greater than or equal to 2. Hence the only solutions that we found in the beginning were of n equal to 1 and n equal to 2, which is 1, 1, 1, 2, and 2, 1. So are there any questions with the proof? We are done. The only solutions are this. Are there any
I like the problem just because of the finish, and you made it so contrived. Like it's complicated.
It's not. It's simple dumb bounding.
Yeah, I'll tell you a simpler way. You will say it's dumber.
Okay, say.
Okay, so go down. You
Go down.
had p minus q thingy. Where is that?
This part.
Yes, n square plus x into n square plus y divides x minus y to the power 4 plus 1. Okay. We know that x minus y to the power 4 can at max be like 16 times that
Yeah,
thing,
yeah.
right?
So the quotient is at most 16.
Yeah. So like you can write this as k times n square plus x into n square plus y equals to x minus y to the power 4 plus 1. And k can be anything from 0 to 16. 1 to 16. Right. Okay. Now let's say k is a multiple of 3. Is it possible that it's a multiple of 3?
Modulo 3. You would have some issues with this. Exactly. You're doing the order argument. You can't write modulo 3. This should get into
Right.
You're doing the order argument. That is, you're literally doing this argument only, right? In an informal way. Your voice is breaking. I can't hear you if you're saying. Your voice is breaking. I'll type you. I'll type.
Okay.
Mathclub is not in this meeting. Yeah, so what you're doing?
No.
No. Your voice is still breaking. Okay, so I got the main idea what you're trying to do. Miro hates me. So you're like saying x minus, like the quotient we had m can't be a multiple of 3 because 3 can never divide x minus y to the 4 plus 1. Similarly 5, similarly 7, similarly anything else. Right?
Yeah. When did you say this?
You said this, no? Oh, this
Yeah,
order
yeah.
argument. Oh. That is any prime that divides the order of x minus y modulo p must be 8. So p must be 1 modulo 8. I did this in the starting. I guess you were not in the meeting at that time.
Oh, okay. Yeah, fine. It's same thing only. Yeah,
Yeah,
fine. I missed that, so I was confused.
Yeah, I did it in the
Yeah.
starting. Yeah. So
Yeah,
is the
fine.
proof clear to everybody else? Are there any questions? If there are any questions, you can type in the chat. If the proof is clear, you can type yes in the chat. Yes, awesome. So I guess you've exceeded time. That's it from my side. So I hope you enjoyed. NT is very good. No, the proof is not clear. Online math club. Anyways, so you're here for. Okay, anyway. That's it from my side. Divisibility is there. So what we essentially did in the first problem, remember, in the first 3 problems, essentially, we never characterized all solutions. Just try to extract as much information as possible. And you may not find a nice properties or any good characterization or all solutions, but we probably may be able to find some structures that they follow. So essentially, nice divisibility ideas, primes are really good. The factorizations can be really helpful. The J factorization may be helpful. Not all, don't remember stuff. Just have a sketch of the proof. Like that 2a squared plus 2a plus 2. Once you see that a to the 4 plus 4, that gives a big edge in the problem. So these factorizations and bounding the multiple nicely. Someone said multiplying by 2 and adding p. That was a nice step. That was a really clever step. So these nice manipulations and the 22 or second problem that we did, right? In which manipulated so nicely that a plus 1 whole cube turned out. So these nice manipulations help a lot. So that's what I wanted to convey mainly. And then orders can be very useful for nice bounding idea. So this problem is mainly because of orders and bounding. And like trying to reduce those two symmetric divisibilities into one divisibility. And try to use conditions so that you end up at just one divisibility or one condition, which is much easier to handle. So I guess I've conveyed a nice message and I hope you enjoyed the class. Thank you for attending. Bye-bye.
Thanks for taking the class.
Thanks for letting me.
Also, can you stop recording?
Yes, sure. Stop recording. Are you sure you want to stop it? Oh, shit. Stop recording.